Hello, in this video we're going to talk about Newton's laws of motion and how to solve math problems involving Newton's laws of motion. First off, the content and language objectives. Content objective is I can distinguish between Newton's laws of motion. Content objective, I can solve Newton's laws math problems. And the language objective is I can write about action-reaction pairs for Newton's third law. Newton's laws of motion, there are lots of Newton's laws. We're just going to talk about three specific ones that involve forces. So Newton's first law, and these are just textbook definitions. We'll go through and more simply explain these as we go. It says Newton's first law is that every object will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of an external force. Newton's second law, it says the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of an object. And Newton's third law says for every action in nature, there's an equal and opposite reaction. And so we'll go through and make sense of those and explain those in simpler terms. Newton's first law, basically what it says is an object in motion is going to stay in motion, and an object is at rest is going to stay at rest unless acted on by an unbalanced force. This is also known as the law of inertia. And basically what this means is that the larger an object is, the more mass an object has, the more inertia it has, and the more difficult it is to move, the more force that is required to move an object. Newton's first law, just some examples of this. An object at rest remains at rest. A soccer ball is not going to move unless it is kicked, unless there's some external force applied to it. And an object in motion is going to stay in motion unless, again, it's acted on by an unbalanced force, such as a net that is slowing it down or the force of friction. Newton's second law, basically what it says is force is equal to mass times acceleration. The inversely and directly proportional, just talking about if you increase something, does it decrease or does it increase? And so this example just shows if you have the same force, you have someone hitting a golf ball or swinging a golf club, that the force is going to remain the same. And if you hit a small object, an object that has a very small mass, such as a golf ball, it's going to accelerate very quickly. If you apply the same force in hitting a truck, which has a great mass, the acceleration is going to be less. And so if you have a small mass, you'd have a great acceleration. If you have a great mass, you'd have a small acceleration. Just another example of this is if you have two train engines and one weight, you have a smaller mass and a larger force, and so you're going to have a large acceleration. If you have one train engine and the same mass, it has a smaller force, and so you're going to have less acceleration. Again, if you have a greater force and a greater mass, your acceleration would be comparable to that second example. Newton's second law, looking at it, it says a net force of 15 newtons is exerted on a book to cause it to accelerate at a rate of 5 meters per second per second. It says determine the mass of a book. And so if you're asked to go through and solve a problem involving force, mass, and acceleration, what I always find is helpful is to draw a picture. And so you have a 15 Newton force pushing to the right, and the object would then accelerate at 5 meters per second to the right. And again, you're asked to figure out what is the mass. You would use the equation force is equal to mass times acceleration. Keeping in mind units helps keep track of what you're doing. And to set up this equation, you know the force, you know the acceleration, you're solving for the mass. And so if you isolate m, put it by its own side on this equation, by dividing by 5 meters per second, you'd come up with a mass of 3 kilograms for that book. Suppose that a cart is accelerating at a rate of 3 meters per second. If the mass of the cart is tripled, how would the acceleration change? For some problems, you're not asked to solve for specific numbers. It's just a theoretical. If you increase this or decrease this, what's the result? And so again, drawing some pictures might help. And so if you have some force, you have X kilogram box. If the mass is tripled, now you have 3 times X, the mass. The acceleration before is 3 meters per second. What would the acceleration be if you tripled the mass? I'm just going to make up numbers for a force. Anytime that numbers aren't given to you, you can make them up and see what the effect is. And so in this case, using the force equals mass times acceleration equation, we know the force, we know the acceleration. And we could solve for what's the mass after we've plugged in a fake number. And solving for the mass, we'd come up with 5 kilograms as our pretend mass using our pretend force. Why is that useful? Because now we can use this mass, 5 kilograms, if we tripled it to see what would happen with our acceleration. And so force, 15 newtons, mass, we know that now, 15 kilograms. We can try to isolate A in this equation and solve for what would the acceleration be. And so the acceleration, if you triple the mass, you have 1/3 the acceleration. And so that is why they are inversely related. If you increase one of these factors, mass, you're going to decrease the acceleration given the same force. Just another way to look at this with a force, mass, acceleration triangle that can be useful for some students rearranging equations. Again, if you triple the mass and you have the same force, what that means is that your acceleration must be cut in third. And you can plug in, again, some fake numbers to see that if that makes more sense. I work better using numbers than just theoretical stuff. Again, suppose the cart is accelerating at a rate of 3 meters per second. If the force was tripled, what would happen to the acceleration? And so if you triple the force and you have the same mass, in order for that equation to work out, you'd have to triple the acceleration. And so that's why force and acceleration might be directly related as opposed to inversely. Inversely, as one goes up, the other goes down. Directly, as one goes up, the other one goes up. Some problems not only involve just force, mass, and acceleration, but they also might involve an angle. And so we've dealt with vectors before in previous units. If you're not familiar with vectors, I'd recommend watching the video on that. But using a little trigonometry, you could solve this problem. So if a 20 Newton force is applied at a 30-degree angle, what would the acceleration of this 4-kilogram box be? And so you can use a cosine function to figure out if you have a 30-degree angle and a 20 Newton force, what is the force in the x direction that you'd be using to pull this box across the floor? And so setting up that problem, 20 times cosine, because this is an adjacent side and the hypotenuse is known, we can solve for the force around that x direction. That's 17.32 newtons. If you know the force, if you know the mass, you can then solve for acceleration. Again, by isolating A, acceleration, you can do that by dividing the mass, dividing by 4 kilograms on both sides of the equation to solve for our acceleration. That's 4.33 meters per second per second. Newton's third law has to do with actions and reactions and how they pair. What the law says in simple terms is that for every action, there is an equal and opposite reaction. And so if you're standing on a boat and you jump off the boat towards the left, the boat is going to move towards the right. Examples of that would be a spaceship taking off, a space shuttle, or hitting a baseball. The action of the ball hitting the bat is equal to the bat hitting the ball. The acceleration of the force and acceleration of the ball moving forward are going to be equal to the force of the bat moving backwards once they make contact. And just another example of how you could solve a sort of problem that involves Newton's second and third laws. It says, suppose that a baseball is hit by a bat. If the ball, 0.25 kilograms, accelerates at a rate of 24 meters per second as it leaves the bat, which is 1.1 kilograms, what would the acceleration of the bat be? And again, for every action, there's an equal and opposite reaction. The action could be the force on the baseball. The reaction would be the force on the bat. And so force on one side of this equation, or for one scenario, is going to equal force on the other. And force is, again, the product, multiplication of mass and acceleration. And so you can't see this at the bottom now, but if you were to multiply the mass and acceleration of the baseball, you'd take 0.25 kilograms times 24 meters per second. If you wanted to figure out the force of the bat, you would have to take the mass times acceleration, but we don't know the acceleration of the bat. That's what we're trying to solve. And so what you can do is set these two equations equal to each other, try to isolate the A for acceleration of the bat by dividing both sides by 1.1 kilograms. And by doing that, you can solve for what would the acceleration of the bat be. And in this case, it would be 5.45 meters per second per second. That is the end of this video overviewing Newton's laws and how you can go through and solve some different math problems involving Newton's laws. If you have any questions, you're always welcome to stop by the office hours, the virtual science homework help, and I'd love to help. Otherwise, shoot me an email. That's it. Have a great day.